Okay, for number 3, we have 3 circles of equal size are inscribed inside a bigger circle of radius 1. So I'm going to try to visualize what they just said. There's going to be this big circle, and inside there's 3 circles, and everything is tangent to one another. Now, visualizing it, what I'm going to do is I'm going to visualize an equilateral triangle between those 3 circles. And I have to say that that might help me figure this thing out. And I want to go to the whiteboard. And same picture, number 3. I'm going to put down a coordinate system to help me out with this equilateral triangle, by the way. And I got something that looks, again, try to center the equilateral triangle over here. Okay. And let me take a look at this. And I'm going to and I got 3 triangles over there. By the way, the center of these smaller circles are here, here, and here. And the center of the big circle is here. Now I got a big circle, and then I got 3 smaller circles in there that are tangent to one another. And what do I know about the length of this side over here? Well, that's where the circles are going to be tangent to one another, so it's going to be 2r here. Okay, I want to point out what I'm talking about over here. I got a triangle over here. This would be 2r, going from center to center. So 2r, the diameter of those small circles. And this over here to the edge of the big circle, there's going to be a center there, is going to be 1 unit long. That's a 1 up there. All right. Again, there's a big circle, smaller circle, so forth and so on. All right, I got to think now. I guess I could start to maybe figure out the triangle, by the way. I'm going to look at, maybe a section of it. This section over here. This would be R. This would be 60. This is 30. And let's talk about the dimensions over here now. And let's take a look at that. So it's a 30, 60, 90. And that should be sort of well known to you. I'm going to divide through by root 3. No, I'm not really doing a great job of drawing over here. 1 over root 3. And this should be 2 over root 3. And then multiply by r. So this dimension over here is going to be 2 root 3r. This dimension over here is 2 root 3r. This dimension over here is 2 root 3 over r. Now what I got to do, I'm going to call this thing x. So let me write this over here. Let me just think about it for a second. I got a circle centered there, big circle's over here, tangent to it. And let me write this down. Well, you know what? That's not really x, that's r. And why is that? The circle's tangent to there. So this is going to be r. This distance here is r. It's where that circle is touching the bigger circle. Plus this. And what's that equal to? 2 over root 3r. And that's equal to 1. Let me make sure I said that right. We figured this thing out, which are the sides. Let me just point out what I mean by that. that we're just doing this thing over here. We got that. And I know the circle, the small circle centered here, has got a radius r and touching the bigger circle. So the big circle, is going to be 1 plus that distance plus the distance of the radius of that circle. And the question is, can you figure out what r is now? Yeah, you can. And let's go through that. And what I'm going to do is I'm going to factor r out. And you get 1 plus 2 over root 3 equals 1. Make sure I did that right. Yep. I'm going to divide both sides by the coefficient on r. I'm going to multiply top and bottom by root 3. You get root 3 on top. On bottom, you get root 3 plus 2. I'm going to multiply the bottom by by its conjugate, which would be root 3 minus 2. And what do you get on top? You get 3 minus 2 root 3. On bottom, what do you get? You get 3 minus 4, which is minus 1. What do you get? R equals 2 root 3 minus 3. That's the radius of the smaller circle, by the way. And we're done. Thank you.